We're simplifying rational expressions today, and this is very technical, so you have to be very detail oriented. So one of the things we're going to start with is by writing the domain. So basically, which x values can't we include in the domain is how we're going to write it. And one thing to remember about rational functions is that a rational function is just a polynomial is polynomial 1 divided by polynomial 2. So since it's a fraction, anything when polynomial 2 is equal to 0, then we have a domain restriction, okay? Or polynomial 2 cannot equal to 0, basically. All right, so let's set our domain first. The first thing we do is to factor everything. That's what we do. Factor first. So number 1, factor. All right, so I'm going to take x squared minus 12. I'm going to use the big X, negative 12 and negative 1. What multiplies to negative 12 and adds to negative 1? That would be negative 4 and 3. And then in the bottom, I have negative 8 and negative 2. So what multiplies to negative 8 and adds to 2? Negative 2, negative 4 and 2. All right, so I am going to rewrite this as in factored form. So x minus 4 times x plus 3 all over x minus 4 times x plus 2. And this is where we get domain before we cancel. So one thing to get our domain, we're going to take the bottom of the fraction and set it equal to 0. So right over here, domain, okay, x minus 4 times x plus 2 is equal to 0. So this is kind of on the side, separate. I can use, since my equation's written in factored form, I can use zero power property. Wow. Okay, so x minus 4 is equal to 0, and the factor of x plus 2, when that equals 0, then the whole equation is equal to 0. Okay, so I get x is equal to 4 and x is equal to negative 2. So what this means is what we're actually looking for is when this function doesn't work when x equals 0. So we're saying the function cannot equal 0, so cannot equal 0, cannot equal 0. So we cannot equal 4 and we cannot equal negative 2. This is my domain, okay? Or we can write it as, actually, let's say x cannot equal negative 2 or 4, so as a list. Okay, next up, we can simplify. So after we get our domain, we can simplify. You are only allowed to simplify factors, so pieces that are being multiplied together. So x minus 4 is multiplying with x plus 2. And then on the numerator, x minus 4 is multiplying with x plus 3. Since I am multiplying something by something, I can go ahead and cancel. So I can cancel out the x minus 4 and the x minus 4. So we're looking for the exact copy from the numerator and the denominator to cancel. So I get this rational expression simplifies to x plus 3 over x plus 2, where x cannot equal negative 2 or 4. All right, next up, let's simplify the next one. We're going to factor or GCF first. So I see that I can GCF out of 4. So I have 4 times x plus 1. In the denominator, I'll use the big X, so 3 on the top, 4 on the bottom. I can multiply 3 times 1 to give me 3 and add to 4. So I get x plus 1 times x plus 3. Okay, chill for a second. We got to set this equal to 0. Cannot equal 0. All right, so we solve with zero product property. X plus 1 is equal to 0, and x plus 3 is equal to 0. So when x is equal to negative 1, we get a 0, And when x is equal to -3, we get a 0. Okay, this means that our domain restrictions are x cannot equal -1 and x cannot equal -3. We'll go back and simplify. I'll just put domain here and put a little box around it. Okay. So I can see that x plus 1 is multiplying with 4, and x plus 1 in the denominator is multiplying with x plus 3. So since those are both multipliers, I can cancel them. So I'm looking for an exact multiplication in the numerator and the denominator. So I get 4 over x plus 3, where x cannot equal -1 or -3. All right, so this is our whole answer here. Okay, we're going to get a little bit more complicated. Now we're multiplying fractions. So how do we multiply fractions? If I had a fraction like 1/2 times 5/3, I would just multiply straight across. So 5 over 2 times 3 is 6. We're going to do the same thing with fractions. We just need to be very mindful of what our factors are. Okay, so we go, oops, we're going to factor first. Factor first. Okay, so out of 6x minus 18, I see I have a GCF. That is the first factoring I always try is GCF. So a 6 is a common factor between 6x and -18. So I get 6 times the quantity x minus 3 all over x 4x squared times x cubed over, and I can see in the denominator, the second fraction, I can also GCF out a 2. So 2 times x minus 3. Okay, before we cancel, we have to get our domain. So our domain is, okay, I have a factor of 4x squared, and I'm going to set that equal to 0. So I divide by 4. I get x squared is equal to 0. So I can see that x is going to equal plus or minus 0, which is just 0. And then the second fraction, I have 2x, 2 times x minus 3 is equal to 0. I divide out the 2. So I get x minus 3 is equal to 0. Solve for x. So x is equal to 3. So I cannot equal 0, and I cannot have an x that equals 3. This is going to be very important in the next lesson for us. Okay, so now that I found my domain, I can go ahead and cancel stuff out. I like to cross cancel. So when I'm multiplying anything from the numerator that cancels with the denominator, from either one of the fractions, we can cancel. So I have 6 and 2, those both divide by 2. So 6 divided by 2 is 3, and 2 divided by 2 is 1. And then I have, this is x times x times x, and in the denominator I have x times x. So 2 x's will cancel. So both of those x's go away, and that leaves me with 1 x in the numerator. The last thing I see that cancels is the x minus 3's. All right, and then anything that's left over, I multiply it together. So I do 3 times x is 3x, and 4 times, it looks like I'm only left over with a 1. Okay, so our simplified expression would be 3x over 4, where x cannot equal 0 or 3. And that is our solution. Okay, let's do another one. All right, so I personally like to factor first because I think it's easier to see what our excluded values are. So top left, I can GCF out a 9. So x plus 2 over, looks like I need to, since I have a trinomial and I don't have a greatest common factor, I'm going to try the big X. So negative 8 and 2. I can multiply 4 times negative 2 to give me negative 8 and add to 2. So I have 4 plus x plus 4 times x minus 2 times, and second fraction is numerator. I'm going to GCF a 3 times x minus 4. All over, okay, 6x. Okay, it's domain time, domain time. I'll just do it on the side. Okay, so I have 3 factors in my domain. I'm going to set them each equal to 0. So first I'm going to take the x plus 4, and I'm going to set that equal to 0. Then I'm going to take the second factor of x plus 2, x minus 2, excuse me, and set that one equal to 0. And lastly, we have to set 6x equal to 0. Solve each. I get x is equal to negative 4, x is equal to, so an x is equal to 0. So when x is equal to negative 4, I would get a 0 in the denominator, so I cannot have x equals negative 4. When x is equal to 2, I would get a 0 in the denominator from that factor, so x cannot equal 2. And when x is equal to 0, in this factor, it's going to zero out our denominator, so I can't equal 0 as well. So there's 3 excluded values, 0, 2, and negative 4. All right, hold that for later. Now it's time to cancel. All right, so I have x plus 2 and an x minus 2. Those are not the same sign, so they need to be an exact copy of itself. Those do not cancel. The x minus 4 and the x plus 4, those don't cancel either. Lastly, it looks like I have 3 out of the 3 and the 6. I can divide out of 3. So 3 divided by 3 is 1, and 6 divided by 3 replaces me with a 2. So 1/2 is the same thing as 3 over 6. All right, I will simplify. I just write 9 times x plus 2 times x minus 4. Remember, we just multiply across. On the denominator, I have 2 times x plus 2, x plus 4 times x minus 2. And that is it, where x cannot equal negative 4, 2, and 0. Okay, last one, we're going to divide fractions. So the first thing I need to do is, of course, factor. Okay, so I get, it looks like I need to big X this first one. Okay, factoring. Got a little off track. Okay, negative 8, negative 2. So I get negative 4 and 2. So the top factors to m minus 4 times m plus 2. The denominator of the first fraction is the greatest common factor. So I can factor out an 8 times m plus 3 divided by, see, it looks like I have a greatest common factor of 2. So I have 2 times m minus 4 all over. I have a trinomial, so I'm going to try the big X. 12 and 7. I can multiply by 4 and 3, giving me m plus 4 times m plus 3. Okay, division is a little different for the excluded values. So for the domain, we have to look at the factors from the denominator of the first fraction, the denominator of the second fraction, And since we're going to keep, change, flip, or multiply by the reciprocal, we also have to look for the factors, look at the factors in the numerator. So I get of the second fraction only. So we're only not looking at the factors from the numerator of the first fraction. All right, so I'm going to set 8 times m plus 3 equal to 0. Then also 2 times m minus 4 equal to 0. And m plus 4 times m plus 3 equal to 0. All right, the 8 will divide out, giving me 0. So m plus 3 is equal to 0. Subtract 3. M is equal to negative 3. So that's one excluded value. The 2 will divide out. So I get m minus 4 is equal to 0. M can equal 4, okay, or it cannot equal 4. That's a second excluded value. All right, I will use zero product property. So m plus 4 is equal to 0. Or m plus 3 can equal 0. Subtract 3. I get m is equal to negative 3. So m cannot equal negative 3 because that's what makes our denominator go to 0. All right, m plus 4, oops, might as well just subtract. I get m is equal to negative 4. So another excluded value is m cannot equal negative 4. All right, now we get to go simplify the fun stuff. When I divide fractions, I'm going to multiply by the reciprocal. That's basically us clearing the denominator in our fraction. So I'm going to write m minus 4 times m plus 2. That's not very pretty. Over 8 times m plus 3. Okay, I change to multiplication and then I reciprocate. So m plus 4 times m plus 3 all over 2 times m minus 4. So the numerator becomes the denominator and the denominator becomes the numerator. All right, we cancel like whoa. I got anything from the numerator and anything from the denominator will cancel. So I get m plus 3 times divided by m plus 3. I got an m minus 4 and an m minus 4. And I think that's it. So what's left is a factor in the numerator of m plus 2 times m plus 4. I can multiply 8 times 2, giving me 16. Let's write that in the middle. 16. Okay, another way you could write this is 1 over 16 times m plus 2 times m plus 4. And what values can we not include? Remember, well, it looks like in the end, see, it looks our like we don't have a denominator, but we know from the original that there were a bunch of values we weren't allowed to use. So we say where x cannot equal negative 3, see these repeat, negative 4, and 4. Okay, that is it. We'll do some practice in class. Woo!